In this video, I will show you how we can prove this relation in three different methods. We want to prove that sine inverse of x plus cosine inverse of x is pi over 2. Two of the methods is based on trigonometric identities and relations, and one of the methods is based on the calculus. Before I show you the methods, first let me remind you something about sine inverse and cosine inverse. As you know, sine inverse of x is inverse of function sine, but we know that sine is not a one-to-one function, so it can't have an inverse function. But because we limit the domain of the sine between negative pi over 2 and pi over 2, so in that region, in that interval, the sine has inverse, and we name the inverse of sine inverse or arcsin. So sine inverse of x is always between negative pi over 2 and pi over 2. This is important for our proofs. The other thing that we need to know is that cosine inverse of x, the answer of the cosine inverse of x, is always between 0 and pi. So whenever, for example, we want to find sine inverse of, let's say, 1/2, there are infinite answers for this. What is sine inverse? Sine inverse means that we want an angle that its sine is 1/2. Pi over 6 is an angle that its sine is 1/2. But also 5 pi over 6, the sine of 5 pi over 6 is also 1/2. And also pi over 6 plus 2 pi, which is 13 pi over 6. The sine of this angle is also 1/2. And there are infinite other answers. But because of this condition, because the answer of sine inverse of x is always between negative pi over 2 and pi over 2, so we reject all of these answers and we only accept this answer for sine inverse. So sine inverse of 1/2 is only pi over 6. This relation, this condition for sine inverse and cosine inverse is important for our proofs with the trigonometric relations. Now let's start the proof of this relation. So we want to prove that sine inverse of x plus cosine inverse of x is equal to pi over 2. The method of the proof is this. We suppose the angle that we get from sine inverse, alpha, and we suppose this angle as beta. So we suppose alpha to be equal to sine inverse of x. We know that an answer of the sine inverse always is an angle. We name that angle alpha. From this relation, immediately we conclude that sine of alpha is x. And we suppose beta to be equal to cosine inverse of x. From this relation, cosine of beta is also x. Now let me draw a triangle for each of these angles, alpha and beta. Suppose this is a triangle, a right triangle, and this angle is alpha. Because sine of alpha is x, because sine of alpha is equal to x, or x over 1, so the opposite side to alpha is x, and the hypotenuse is 1, because sine is opposite over hypotenuse. With Pythagorean theorem, we can find the length of this side of the triangle. If we use the Pythagorean theorem, if we suppose this as a, then a to the 2 plus x to the 2 is 1. And from this, a to the 2 is 1 minus x to the 2. And so a equals plus minus radical 1 minus x to the 2. So the length of this side of the triangle is plus minus radical 1 minus x to the 2. So this side is plus minus radical 1 minus x to the 2. But attention, the angle alpha is, which is sine inverse of x, is always between negative pi over 2 and pi over 2. When an angle is between negative pi over 2 and pi over 2, it means that that angle is in quadrant 1 and quadrant 4. Negative pi over 2 is here, pi over 2 is here. In this region, which is quadrant 1 and quadrant 4, the cosine is always positive. So for any angle that is in quadrant 1 and quadrant 4, the cosine is always positive. Remember, all students take calculus. In quadrant 1, everything is calculus, all is positive, and in quadrant 4, cosine is also positive. So cosine is always positive for any angle that is in quadrant 1 and 4. Why I am explaining this to you? Because I want to tell you that in this triangle, cosine of alpha, cosine of this angle alpha, is adjacent, which is this, over hypotenuse. But cosine is always positive. So between plus minus radical, which answer we accept? Only the positive. So this side is only radical 1 minus x to the 2. It can't be negative because cosine is positive. So radical 1 minus x to the 2 is the length of this side. Now focus on this relation. Cosine of beta is x. Let's draw a triangle for that. This is triangle for beta. If we suppose this as beta, cosine of beta is x, so the adjacent is x. The hypotenuse is 1 because cosine is adjacent over hypotenuse. Similar to the previous part for sine, easily we can see that the length of this side is radical 1 minus x to the 2. And only, again, we accept only the positive sign. We don't accept the negative. The reason for that is that, attention, the angle beta, attention, beta is cosine inverse of x. The angle beta is between 0 and pi. For any angle that is between 0 and pi, 0 to pi is quadrant 1 and quadrant 2. In these two quadrants, sine is positive. Sine is positive because if you remember, all students take calculus, all the trigonometric functions are positive here. In the second quadrant, sine is positive. So in these two quadrants, sine is positive. Look at this triangle. What is cosine of beta? What is sine of beta? Sine of beta is opposite over hypotenuse. So radical 1 minus x to the 2 can be the sine of beta, but not negative because sine is always positive in quadrant 1 and quadrant 2. So we only accept the positive sign for the length of this side. Now look at these two triangles. We have every side of the triangles. Now we can finish our proof for this relation. Now we want to prove that with the aim of these triangles and the sum formula, we want to prove that this relation is true, that sine inverse of x plus cosine inverse of x is pi over 2. So we want to prove that alpha plus beta, alpha is this, beta is this. So we want to prove that alpha plus beta is pi over 2. This is our aim basically. We want to show this relation is true. For that, to prove this relation, we use the sum formula for alpha plus beta. Let me remind you the formula for sine of alpha plus beta. From the sum formula for sine, we know that sine of alpha plus beta is always sine of alpha cosine beta plus cosine of alpha sine of beta. By using these two triangles, simply you can find sine of alpha, cosine of beta, cosine of alpha, and sine of beta. With the aim of these two triangles, you can find these values. Let's find the values of each of these. What is sine of alpha? If you look at this triangle, sine of alpha is opposite over hypotenuse. Opposite is x, hypotenuse is 1, so x. What is cosine of beta? Cosine of beta, if you look at this triangle, cosine is adjacent over hypotenuse and cosine is again x. And actually you have cosine of beta here, x. So x times x plus. Now, what is cosine of alpha? Cosine of angle alpha is adjacent over hypotenuse. Adjacent is radical 1 minus x to the 2. And hypotenuse is 1, so cosine of alpha is radical 1 minus x to the 2. For sine of beta, sine is opposite over hypotenuse. Sine is opposite. Opposite is radical 1 minus x to the 2 again. Now let's simplify this. If you attention, this is x to the 2. What is radical 1 minus x to the 2 times radical 1 minus x to the 2? It is 1 minus x to the 2. Now if we add x2 to 1 minus x2, the sum of these two is 1. So this equals 1. So far, we have to prove that sine of alpha plus beta is 1. Now from this, we want to conclude that the alpha plus beta is pi over 2. Because remember, sine of pi over 2 is 1. Now we have this relation. Sine of this angle is also 1. So from this, we want to conclude that alpha plus beta is pi over 2. Because sine of pi over 2 is also 1. But there is a problem here that you have to notice. The reason that at the beginning of the proof I mentioned these relations is exactly for here. Please attention. Sine of pi over 2 is 1. Yes, that's true. But sine of 5 pi over 2 is also 1. Sine of 9 pi over 2 is also 1. So how we know that alpha plus beta should be equal to pi over 2? Why not equal to 5 pi over 2 or 9 pi over 2? Now we can use these relations that here we have to reject other answers. Please attention. This is important part of the proof. And if you miss this part, your proof is not complete. Your proof is not perfect. You have missed something. Please attention. We know that angle alpha, which is sine inverse of x, is between negative pi over 2 and pi over 2. So we know that angle alpha is between negative pi over 2 and pi over 2. So this is angle alpha. And we know that the angle beta is between 0 and pi. So if alpha is between negative pi over 2 and pi over 2, and beta is between 0 and pi, then alpha plus beta would be between negative pi over 2 plus 0, which is negative pi over 2. And its maximum would be pi over 2 plus pi. Pi over 2 plus pi is 3 pi over 2. So, by adding this inequality and this inequality, left side to the left side, middle to the middle, and right side to the right side, we get to this relation. So, now we have this condition for alpha plus beta. We know that sine of alpha plus beta is 1. And also we know that alpha plus beta is between negative pi over 2 and 3 pi over 2. In this region, in this interval, from negative pi over 2 to 3 pi over 2, the only angle that its sine is 1 is pi over 2. So, don't forget, because of this relation, the only answer for the equation is alpha plus beta is pi over 2. So that's the reason that we do not accept, for example, 5 pi over 2 or 9 pi over 2 or negative 3 pi over 2. All of these angles, their sine is 1. But the only one that satisfies the last condition, this condition, is pi over 2. So alpha plus beta is pi over 2. And this completes our first proof for this relation. Don't forget, the alpha is sine inverse of x. The beta is cosine inverse of x. So we have proved that. So let me rewrite this again in the terms of sine inverse and cosine inverse. So from this we have arcsine or sine inverse of x plus arc cosine of x is pi over 2. Now let me show you another proof for this relation. So in another method, we want to prove that arcsine of x or sine inverse of x plus arc cosine of x is pi over 2. In this method, we suppose this as theta again. If theta is arcsine of x, immediately we conclude that sine of angle theta is x. Now let me remind you a formula from trigonometry. Sine of theta is always equal to cosine of pi over 2 minus theta. If you don't know this relation, or if you don't remember this relation, or you want to see a proof of this relation, at the end of this proof, I will show you the proof of this relation to you. But for now, accept this relation from me, and then at the end of this proof, I will show you the reason for this relation. So we have this relation between sine and cosine. Sine of theta is the same as cosine of pi over 2 minus theta. Now by combining these two relations, attention, x is sine of theta. Also sine of theta equals this. So from these two relations, we can conclude that x is equal to cosine of pi over 2 minus theta. From this relation, that cosine of pi over 2 minus theta is x, from this relation, now we conclude that cosine inverse of x is pi over 2 minus theta. To get rid of this cosine, we use the inverse of cosine. We eliminate this function from here and we apply its inverse to the other side. When cosine of an angle is equal to a number, then cosine inverse of that number would give you that angle. But there is something that, again, it's important and you need to consider that. If without any reason you from this relation you conclude this relation, this is not completely right. Let me show you the reason that not always for any theta in general from this relation you can get this relation. Let me tell you the reason. For example, look at this. Cosine of pi over 2 is 0. Also, cosine of 5 pi over 2 is 0. And cosine of 3 pi over 2 is also 0. So as you can see, we have different angles that their cosine is 0. If, for example, from this relation, we write something like this. We write that cosine inverse of this number is equal to this. Is this right? No. Cosine inverse of 0 is 5 pi over 2? No, it's not. Because we know that cosine inverse, remember, in the other proof that I showed you in this video, I mentioned that sine inverse of x, sine inverse of any number between negative 1 and 1 is always between negative pi over 2 and pi over 2. And for cosine inverse, I mentioned that cosine inverse is always between 0 and pi. So cosine inverse of 0 cannot be equal to 5 pi over 2 because it's always between 0 and pi. And basically cosine inverse of 0 is pi over 2, not 5 pi over 2. So not for every angle you can eliminate cosine and you can put cosine inverse of the other side. But for this one, if you have cosine of pi over 2 equals 0, from this relation, if you conclude that cosine inverse of 0 is pi over 2, yes, this is right. Only for angles, please attention, only for angles that are between 0 and pi, from a relation like this, you can conclude this relation. So let's back to our proof. So here I want to tell you the reason that in this case, from the above relation, why we can conclude that cosine inverse of x is pi over 2 minus theta. Let me tell you the reason for this. And let me write instead of cosine inverse, arccosine of x. Because in this proof I am using arcsin and arccosine, not sine inverse, cosine inverse. So let me erase this and write it instead this notation, arccosine of x. Why in this case we can conclude from that relation, this relation? Because, please pay attention. The theta that here we have is arcsine of x. So we know that. So from this relation, we know that theta is always between negative pi over 2 and pi over 2. This is because arcsine is always between negative pi over 2 and pi over 2. From this relation, if we multiply both sides by a negative, then we have this relation. Negative theta is between, again, negative pi over 2 and pi over 2. By multiplying both sides by a negative, don't forget you have to flip these signs. You have to flip the signs and we get this relation. Now, if we add pi over 2, if we add pi over 2 to the left side, to the right side, and the middle, what we get? By adding pi over 2 to this relation, we have this pi over 2 minus theta is between 0 and pi. By adding pi over 2 to this, we get 0. By adding pi over 2 to pi over 2, we have pi. Now please attention. The angle that here we have is between 0 and pi. And when an angle is between 0 and pi, then we can eliminate cosine and we can write arccosine on the other side. Because arccosine of x is inverse of cosine whenever the angle is between 0 and pi. So this relation here now is right. These details in these proofs are really important. In many cases, you can see that from this relation, they conclude this without explaining why we can conclude this. Because not always for any angle this relation is right. You have to consider that cosine has inverse, which is arccosine. But the inverse of cosine is arccosine only when the angle satisfies some conditions. Okay, let's continue our proof. We are almost done. We finished almost our proof. Look at this. We know that theta is arcsine of x. And also we have this relation. Arccosine of x is pi over 2 minus theta. So we have this relation. Let me name this relation number 1. And let me name this relation number 2. From 1 and 2, if we add these two relations, what we conclude? Please attention, I want to add this to this, and I want to add this side to this side. So, by adding relation 1 and relation 2 to each other, we have this arcsine of x plus arccosine of x is equal to theta plus pi over 2 minus theta. Minus theta with theta cancels and it equals pi over 2. Let me fix this here. Arcsine of x plus arccosine of x is pi over 2. This is another way that we can prove this important relation between arcsine and arccosine. But before I show you the next method for the proof, let me show you why this relation is true. Why sine of theta is the same as cosine of pi over 2 minus theta for any theta. So I want to show you this relation. For proving this relation, let me remind you this. Cosine of alpha minus beta, we have this relation in trigonometry, is equal to cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. For any alpha and beta, we have this relation. Now I want to use this relation for this side. And I want to write this using this relation. By using this relation, we can write cosine of pi over 2 minus theta in the form of cosine of pi over 2, cosine of theta, plus sine of pi over 2, sine of theta. Cosine of pi over 2 is 0, so all of this is 0. Sine of pi over 2 is 1. 1 times sine of theta is sine of theta. And this shows that this relation is right for any theta. In many textbooks or in many other videos, you can see that for the proof of this relation, they draw a triangle like this, and they put a theta, for example, here, and they say if here is theta, here is pi over 2 minus theta, which makes sense, because if here is theta and this is right triangle, if this angle is theta, the other angle is pi over 2 minus theta. And if this angle is theta, and we suppose this side x, sine of theta would be x over 1. What is cosine of this angle? Cosine is adjacent, and the adjacent is again x. Cosine of pi over 2 minus theta is also x. So this equals x as well. So sine of theta is x, cosine of pi over 2 minus theta is also x. So this can be considered another proof for this relation. But there is a problem with this proof. This is not a complete proof, because when you draw this triangle this way, and you suppose the angle theta here, the opposite side is x, hypotenuse 1, there is a problem here. That here, for this relation, theta is not necessarily between 0 and pi over 2. Maybe theta is 2 pi, 3 pi, 5 pi over 6, 10 pi over 3. So we have this relation in general for any value of theta, but when you draw a triangle, you consider theta only between 0 and pi over 2, because one angle is pi over 2, there it is right triangle, one angle is 90 degrees, so the theta maximum can be between 0 and pi over 2. But this relation is true for any theta. And attention, when we suppose this as theta, theta is between negative pi over 2 and pi over 2. But when you draw this triangle, you suppose the theta to be between only 0 pi over 2. So between these two proofs, I recommend you not to consider this a complete proof. This is not a perfect proof, because it's only true for theta between 0 and pi over 2. This other proof that I showed you here, this proof, is better than the other one. So this is better way to prove this relation here, and this completes our proof. Now let me show you another way that we can prove that arcsine of x plus arccosine of x, or cosine inverse of x, is pi over 2. Here we want to use our knowledge from calculus. If you are not familiar with calculus, you can ignore this proof and you can consider the other. You can just use the other proofs that I showed you here. Let me show you the other proof. In this proof, we suppose this expression a function like f of x. So we name function f of x arcsine of x plus arccosine of x. And we forget whatever is given here. Just focus on the left side. Now I want to show you that this expression is always pi over 2 with the knowledge that we have from calculus. So we have defined f of x arcsine of x plus arccosine of x. From calculus, you should be familiar with derivative. Let's take derivative of this function. Derivative of arcsine of x from derivative formulas, if you remember, is 1 over radical 1 minus x to the 2. And derivative of cosine inverse of x, or arccosine, is negative 1 over radical 1 minus x to the 2. And as you can see, derivative of the function f of x, f prime of x, is 1 over radical 1 minus x to the 2 plus negative 1 over radical 1 minus x to the 2. And this equals 0 because denominators are the same, add numerators, and it equals 0. Now remember, when derivative of a function is 0, it means that that function is a constant, because derivative of a constant is only 0. Derivative of any other function is not 0. So because f prime of x, because f prime of x is 0, so f of x, the original function, is always a constant. We know this. If you remember derivative rules, derivative of a number like 2 is 0. Derivative of a number like 5 is 0. Derivative of radical 2 is 0. Derivative of pi over 2 is 0. Derivative of any constant is 0. But derivative of any other function is not 0. Here we took derivative of the function f of x, and derivative is 0. So the function, the original function, arcsin of x plus arccos of x is a constant. But we don't know that constant. Maybe it's 1, maybe it's 2. So far we have proved that arcsin of x plus arccos of x is always a number, a constant. But we don't know the value of that number. Now we want to show that that constant should be pi over 2. Because it is a constant. So for any value of x, this constant is the same. Now here you can use a random number for x, but that random number should be between -1 and 1, because arcsin or cosine are always defined between -1 and 1 when x is between -1 and 1. So now you can use a random number for x to find that constant c. For example, you can use 0. If we use 0 and we substitute 0 for x to find c, then we have arcsin of 0 plus arccosine of 0. The sine, the angle that its sine is 0 is 0. The angle that its cosine is 0 is pi over 2. So the sum of these two is pi over 2. So from this we conclude that the c is pi over 2. So we have proved that the sum of these two functions is always a constant, and that constant is pi over 2. So we have proved that this equals pi over 2. And this finishes our proof with the calculus method. Now that we have finished this, let me tell you something. Maybe you think if I use another number, maybe I get another number. No, it's a constant. So it means that any number that you substitute for x, always you get at the end the same number, which is pi over 2. For example, suppose you substitute here 1/2. What is the angle that its sine is 1/2? Pi over 6. What is the angle that its cosine is 1/2? Pi over 3. Sum of these two is pi over 2. So as you can see, any number that you use, the answer would be the same, and it's pi over 2. So we have shown that arcsin of x plus arccosine of x is always pi over 2. It's constant. I hope you like this video. If you like this video, please subscribe in my channel, and see you in the next videos.